Welcome all on the video tutorial on machine learning, and in today's session we'll discuss about the fourth module, and we are discussing in the second session of our fourth module, which is Bayes theorem and concept learning. Now we'll see how the Bayes theorem is related to the concept learning, how the Bayes theorem is used in machine learning. Okay, what we do in machine learning is we develop a model, and that model will be predicting your output. How this model is going to predict, since we have trained the machine already with some set of training sample data. Okay, we give a training sample data to machine and we make a machine to learn its features. So whenever input is given, it is going to predict that, it is going to map the given input with the learned data sets, and it is going to give you the prediction. Okay, and we mainly use Bayes theorem for two reasons. One is Bayes theorem is providing you the principal way for calculating your posterior probability of each and every hypothesis when the training data is given. Okay, that is this Bayes theorem is providing a simple way for calculating the probability of a hypothesis of each input. So what is hypothesis? It is nothing but it is a model. Okay, hypothesis is nothing but it is a model where the approximation function takes place, for approximation of a target function takes place by mapping our input to the output. That we say it as hypothesis. So this Bayes theorem is providing you a simple method to carry over to predict the hypothesis. And next is, it is a straightforward learning algorithm. This Bayes theorem is providing you the straightforward learning algorithm for calculating the hypothesis, and it is going to, whenever you give an input, it is going to it is going to analyze that, it is going to map your input with the already trained data set, and it is going to produce the output. Next we'll see the Bayes theorem and what is the ultimate goal for Bayes theorem. We use Bayes theorem to determine the most probable hypothesis when the data is given, and what is the probability of the occurrence of a given hypothesis. Okay, for that we need to know the priority of H. Okay, what is this priority of H? It is going to reflect any background knowledge related to the hypothesis. It is going to reflect that in the prior probability of H. Then we have a prior probability of D, which is reflecting the knowledge from the observed data. Okay, it is going to give the input from the observed data, and which is helping you in the predicting the hypothesis. Then we have a conditional probability. Okay, that is probability of D given H. Here D, the probability of D has occurred after the occurrence of the probability of hypothesis H. Then we have posterior probability of H. Here it is representing that H holds given the observed training data D. When a training data has been given as a prior information, it is going to give you the prediction of the hypothesis. Then we have a Bayes theorem, and we compute Bayes theorem as probability of H given D. It means the hypothesis H has occurred after the data set, and the formula what we use is, for the Bayes theorem is probability of H given D will be equal to probability of D given H multiplied with probability of H, where the probability of D is already been stated. We will see some of the formulas that we use in the probabilities. First is product rule, next we have sum rule, then we have theorem for a total probability. See, what is product rule? Product rule specifies that product of A given B will be, product of A and B will be the product of A given B multiplied with the probability of B, which is again either you have the probability of A given B or the probability of B given A. What is that? The probability of A given B represents the event A has occurred after the B. Okay, this is product rule. You are going to multiply the probability of instant A and B. Then we have a sum rule, which is the two disjunct function of both the events A and B. Okay, with the sum rule states that probability of A plus probability of B will be the probability of A enters a disjoint of the B. Okay, this is the formula we use for sum rule, and for the total probability we use the formula probability of B is given by summation of I to n. The limits are from I is equal to 1 to n with the probability of B given A multiplied with the probability of A. We'll see how what is the relation we have with that of probability with that of concept learning. Okay, for a given set of instances, say the instances may be from x1 to xm. Okay, in that set of data we are going to apply a classification, that is D. Assume D is a set of classification. So what we are going to do, we are going to classify the data in the data set in the given instance. The given instance is x1 to xm, and we are going to classify that in the data set of D. Now we are going to choose the calculate the probability of D given H. Okay, if probability of D given H is 1, we represent that H is consistent with D. Since the output what we obtained is 1, okay, it represents that your prediction will be true and your D of H is consistent with D. Otherwise, okay, if probability of D given H is 0, what we are going to do, we are going to apply an uniform distribution function. We are going to choose the uniform distribution function. The formula used for that is the probability of H will be 1 by the hypothesis for all H in the hypothesis. Okay, the small h is nothing but the consistent hypothesis which is going to occur in a space. Your real mapping of input to that of your output is done by the concept of Bayes theorem. You have already trained your machine with data sets, and we implement an mathematical concept, that is probability concept, which uses Bayes theorem for mapping your input function to the output function. This mapping we do by the algorithm, and we implement the concept of Bayes theorem for constructing a model, and that model, the model that we have developed is going to predict the prediction whenever input is given. Okay, whenever input is given, it has to find the hypothesis of the given event. How it is finding out the hypothesis? Using the probability distribution function, where it is probably using the Bayes concept. Bayes theorem concept for implementing the algorithm. This is what a relationship we have between the Bayes theorem and with that of a concept learning. So what is the concept here? The concept is that we are going to train the machine with a given set of data. Okay, we train a machine with a given set of data, and the machine learns the data, and whenever the input is given, it is going to map that input with your output function. How it is mapping? By observing the trained data. Since it has already been trained, it is going to compare the given input with the trained data, and if it matches, the trained data is matching with the given input, it is going to predict the model. The model what we have developed will be predicting it as true, that is, it is going to give the output as 1, otherwise it is going to give you the output as 0. To give that input, okay, to give an binary input 1 and 0, we use this mathematical concept. We are applying Bayes theorem. Okay, whenever the hypothesis, we are supposed to determine the hypothesis, we will find the probability of the hypothesis to determine the output. Okay, we do this through the algorithm. This is what the relationship we have between the Bayes theorem and the concept learning. The machine starts learning the data, and the mapping of your input with the learned data is done through the concept of Bayes theorem. Okay, this is how we implement algorithm in a machine learning. Okay, with this, your second session of your Bayes theorem with concept learning is over. Thank you all.